So in previous lecture we have seen the derivation, that is derivation for a stiffness matrix for constant strain triangle element. Here is the example related to the CST element. So this example is about to determine the stiffness matrix for the CST element shown in the figure. The coordinates are given, all are in mm, and assume the case of plane stress. The Young's modulus, Poisson ratio and thickness are given. So the coordinates x1, y1, x2, y2, x3, y3 is important to make the area of the element and the strain displacement matrix, to make the strain displacement matrix. So first of all, x1 is equal to, the coordinate of x1 is equal to 20 mm and y1 is equal to 30 mm, x2 is 80 mm, y2 is 30 mm, x3 is 50 mm, y3 is 120 mm. So our strain displacement relationship are about to substitute the coordinates only. And now what is the formula for the stiffness matrix? It is over a volume integral of B transpose dB into dV. So it can be extended as B transpose dB area into thickness. The volume can be written as area into thickness. So K stiffness matrix is equal to B transpose dB into area into thickness. The area of the triangular element, we know from the previous derivation, the area of the triangular, area of the element A is equal to half of the determinant of the matrix 1 x1 y1. So kindly refer the derivation of CST element 1 x2 y2 1 x3 y3. So the determinant of the matrix multiplied by half is the area of the element. So now we have the coordinates. So we can substitute half. x1 is 20, y1 is 30, 1, x2 is 80, y2 is 30, 1, x3 is 50, y3 is 120, y3 is 120. So find out the determinant of the matrix. So half into 1 into the cofactor plus 1 into 80 into 120 minus 50 into 30. 80 into 120 minus 50 into 30. Okay. Next minus 20 into 120. If you eliminate this column and the particular row, it is 120 minus 30. 120 minus 30 plus 30. 50 minus 80. 50 minus 80. So over. So it is half into, the values are 9600 minus 1500 minus 90 into 20, so 1800 minus 30 into plus 30. So it is minus 900. So it is 2700 mm square. The area is 2700 mm square. Okay, next one, the strain displacement matrix. The strain displacement matrix. What is strain displacement matrix? It is B. It is B matrix. So the B matrix for CST is 1 by 2A, 1 by 2A, you know, Q1 0, Q2 0, Q3 0. So totally 6 components, 6 elements of matrix should be available. Next one, it is all about dV by dx. So 0 R1, 0 R2, 0 R3. Next one, combined dou u by dou y plus dou v by dou x. The formula for this dou. So it is R1, Q1, R2, Q2, R3, Q3. So we know each and every term of Q1 representing the coordinate y2 minus y3. Q2 is y3 minus y1. Q3 is y1 minus y2. It is from the derivation of CST element. Next one, R1 is equal to x3 minus x2. R2 equal to x1 minus x3. R3 equal to x2 minus x1. So these are the coordinates to calculate the R1, R2, R3 and Q1, Q2, Q3. So now we can find the value of y2 minus y3 is 30 minus 120, which is minus 90. Y3 minus y1 is 120 minus 30, which is equal to 90. Which is equal to 90. Sorry. Next one, y1 minus y2. Y1 minus y2. Y1 minus y2 is Q3 is 30 minus 30, which is equal to 0. R1 is x3 minus x2 is 50 minus 80, which is minus 30. R2 is x1 minus x3, 20 minus 50, which is minus 30. R3 is x2 minus x1, which is 80 minus 20, which is equal to 60. Now I am substituting the value. I know the area of triangle is 2700. Q1 value is minus 90. 0 Q2 value is 90. 0 Q3 value is 0. So all of 0. 0 R1 value is minus 30. 0 R2 is minus 30. 0 R3 is 60. R3 is 60. Next, R1 is minus 30, Q1 minus 90, R2 minus 30, Q2 90, R3 60, Q3 0. Okay. I am taking 30 outside, 30 by 2 into 2700. So it is minus 3, 0, 3, 0, 0, 0. 0 minus 1, 0, minus 1, 0, 2. Minus 1, minus 3, minus 1, 3, 2, 0. So after taking 30 outside, the strain displacement matrix is this. Okay, next one, we move on to D matrix, because the formula for the stiffness matrix is B transfers dB into AT, dB into AT. So what is D matrix? It is from constitutive relation for plane stress case. For that only we have derived the constitutive relation for plane stress as well as plane strain case. So 1 gamma 0, gamma 1 0, 0 0 1 minus gamma by 2, where gamma is the Poisson ratio. Gamma is the Poisson ratio. So finding out this constant, it is I think 5.555 into 10 power minus 3. 5.555 into 10 power minus 3. So the D matrix, the Young's modulus is 210 gigapascal. 210 into 10 power 3 Newton per mm square. So I am going to write 2.1 into 10 power 5 divided by 1 minus 0.25 is the Poisson ratio. 1.25 0 0.25 1 0 0 0 0 0 1 minus 0.25 by 2. 1 minus 0.25 by 2. By simplifying, 2.1 into 10 power 5 divided by 0.9375. 1.250, 0.2510, 001, that is 0.375. So I am taking 0.25 outside. I am taking 0.25 outside, so that 2.1 into 10 power 5 into 0.25 divided by 0.9375. So it is the 4 times of 0.25 is available in 1. So 4, 1, 0, 1, 4, 0, 0, 0, 0.375, it is 1.5 times available. So 1.5. So if you simplify this, it is 56 into 10 power 3. So now you multiply D into B, because we need B transpose DB. So that first I multiply D with B. D is 56 into 10 power 3. The matrix 4, 1, 0, 1, 4, 0, 0, 0, 1.5 with 5.555 into 10 power minus 3 of minus 303000. 0 minus 1, 0 minus 1, 0, 2, minus 1, minus 3, minus 1, 3, 2, 0. So I am multiplying the constant 56 into 10 power 3 into 5.555 into 10 power minus 3 is 311.08. And so first I am going to multiply 4 into minus 3 plus 1 into 0 plus 0 into minus 1. So this row with this column. So it is minus 2. So the first row with the second column. First element is 0, last element 0. So it is minus 1. The first row with the third column, it is plus 12. All other two items are 0. The first row with the fourth column, it is minus 1. Minus 1. First row with the fifth column is 0. First row with the last column, it is 2. Similarly, you multiply other terms. Minus 3, minus 4, 3, minus 4, 0, 8. Minus 1.5, minus 4.5, minus 1.5, 4.5, 3, 0. I am going to the next step, B transpose DB. So B transpose is 5.555 into 10 power minus 3. So I am going to transpose the B matrix. Minus 3, 0, minus 1, 0, minus 1, minus 3, 3, 0, minus 1, 0, minus 1, 3, 0, 0, 2, 0, 2, 0. And the resultant DB matrix, it is 311.08 minus 12 minus 1 12 minus 1 0 2 minus 3 minus 4 3 minus 4 0 8 minus 1.5 minus 4.5 minus 1.5 4.5 3 0. So when you multiply the constant, it is 1.728. So the first row with the first column, minus 3 into minus 12, it is 36. The second element is 0. Third element is plus 1.5. So it is 36 plus 1.5. The second is second column, minus 3 into minus 1 plus 4.5. So 3 plus 4.5. Next one, minus 36 plus 1.5. 3 minus 4.5. Minus 3 minus 6. So next row, 3 plus 4.5. 4 plus 13.5. Minus 3 plus 4.5. 4 minus 13.5. Minus 9 minus 8. The third row with the first column, it is minus 36 and plus 1.5. Minus 36 plus 1.5. Similarly, minus 3 plus 4.5. 36 plus 1.5. Minus 3 minus 4.5. Minus 3, 6. The next fourth row, it is the first element is 0. So minus 1 into minus 3 is plus 3. And 3 into minus 1.5, it is minus 4.5. So 3 minus 4.5, 4 minus 13.5, minus 3 minus 4.5, 4 plus 13.5, 9 minus 8. The fifth row, 2 into minus 1.5 is minus 3. 2 into minus 4.5 is minus 9. Similarly, minus 3, 9, 6. Last is 0. The last row, mid element is only available 2. So it is minus 6, minus 8, 6, minus 8, 0, 16. So now half of the way we have calculated the B transpose dB. Finally, we have to multiply the B transpose dB with area into thickness. Area into thickness to get the stiffness matrix. So the stiffness matrix K is equal to 1.728. The first value is 37.5, 7.5 minus 34.5 minus 1.5 minus 3 minus 6, 7.5, 17.5, 1.5 minus 9.5 minus 9 minus 8 minus 34.5 minus 31.5 plus 1.5 37.5 minus 7.5 minus 3 6 minus 1.5 minus 9.5 minus 7.5 plus 17.5 9 minus 8. So minus 3 minus 9 minus 3 9 6 0. Last 2 0, there is no manipulation. Summation minus 6 minus 8 6 minus 8 0 60. Okay, this is the matrix multiplied by 2700 into 10. 2700 into 10. So the mid matrix, the matrix is not going to change, only the constant value, it is 46.656 into 10 power 3 into the same matrix, into the Same matrix is the stiffness matrix for the CST element, given CST element. Similar problems can be asked in your examination. So I'm going to give some assignment for practice on the analysis of beams, stresses and the CST element.